Welcome to the lesson on section 5.1, Areas and Distances. In this lesson, you'll learn about using left endpoint, right endpoint, or midpoint estimation to approximate the area under a curve. Suppose we need to estimate the area under the curve f of x equals 25 minus x squared between x equals 0 and x equals 5 using 5 rectangles. There are a few different ways we can draw these rectangles under the parabola. First, we'll use what's called left endpoint estimation, or a left-hand Riemann sum. If we use 5 rectangles from x equals 0 to x equals 5, each rectangle will have a base of 1 unit. Left endpoint estimation means that the upper left corner of each rectangle will be a point on the curve, like this. To find the total area of the 5 rectangles, instead of adding base times height for each individual rectangle, we'll calculate the base times the sum of the heights, since the base of each rectangle is the same. The height of the first rectangle is the value of f of 0. The height of the next rectangle is the value of f of 1, and so on. That makes our total area 95. You can see from the diagram that this is an overestimate of the actual area under the curve. Do you think left endpoint estimation will always result in an overestimate? The right endpoint estimate, or right-hand Riemann sum, would look like this. Notice that the upper right corner of each rectangle is a point on the curve. So the height of the first rectangle would be f of 1 here instead of f of 0. You can see from the diagram that the right endpoint estimation will be an underestimate of the actual area under the curve. So do you think right endpoint rectangles will always result in an underestimate? Let's look at how to find that sum using your graphing calculator. Press alpha F2 and choose number 2, summation. Enter x as the variable in the first box. Set the starting and ending x values at 1 and 5 to add from f of 1 to f of 5, and enter the formula of the curve in the parentheses. The right endpoint sum is 70. Midpoint estimation means that the midpoint of the upper base of each rectangle will be a point on the curve. So in this case, the heights line up with x equals 0.5, 1.5, 2.5, and so on. Don't forget that we're really calculating base times height for each rectangle, but so far our rectangles have had a base length of 1. Suppose in the same region we use 10 left endpoint rectangles. The rectangles would look something like this, and base times height for each rectangle would look like this. I'll leave it up to you to finish calculating this estimate. This concludes our lesson on section 5.1, Areas and Distances.